right, welcome back to our discussion about the analysis of graphs and the attributes of functions. And in this video, we are going to talk about how do we evaluate functions for a specific value or expression, and then how do we identify a function from a graph. So let's jump in. Sometimes we are given a defined function, such as the one you see here, f of x is equal to x squared minus 10x minus 3. And we're asked to evaluate specific function values. So when I see something that looks like this, f of 3, that's really saying, what is the y value when I substitute 3 in for every x in the function? Okay. So notice every 3 or every x in this defined function has been replaced with 3. Okay. So when 3 replaces the x here, it must replace all the other x's. And then you're just going to use what you know about order of operations to evaluate. So we would take 3 and square it. We would subtract 10 minus 3 and then subtract 3 again. So 9 minus 30 minus 3. So f of 3 would end up being negative 24. Now if you're looking at f of a, again, you're replacing x with a, right? We're taking this x and replacing it with a. So that means we're going to take every other x and replace it with a as well. And then we simplify it and combine like terms, but there are no like terms in this case. So we can just say that that's good as it is. For this next one, we are going to take x and replace it with negative x. So everywhere I see an x, I'm going to substitute in a negative x. So negative x squared minus 10 times negative x minus 3, and that's going to end up being positive x squared plus 10x minus 3. And then the last thing here is probably where it gets the most interesting. And it's the same idea. This x here in our defined function has been replaced with the quantity x plus 2. So everywhere I see x, I'm going to replace it now with x plus 2. So we're going to take x plus 2 and square it, and then we're going to subtract 10 times x plus 2, and then we're going to subtract 3 from that. So we would end up with x squared plus 4x plus 4 minus 10x minus 20 minus 3. And then we would take all like terms and combine them together, and we would end up with an expression of x squared minus 6x minus 19. Okay, that's the process for evaluating functions for a specific value or expression. Now let's take a look at some graphs. So we want to think about, so when we are looking at graphs and we want to determine whether or not they represent functions, we want to see if the graph passes the vertical line test. And sometimes we just abbreviate that with VLT. Okay? So a graph will pass the vertical line test if any vertical line drawn touches or crosses through the graph at most one time. So what you need to do here is visualize every possible vertical line that you could possibly draw, okay, to apply the vertical line test. And if the graph fails at any point, then the graph does not represent a function. So here are some sketches of graphs, and we want to think about, do they represent functions or not? So if we look at this first example, looks like a graph of something linear. We are going to think about all kinds of vertical lines. And if I draw vertical lines anywhere, it will not cross that graph more than once. And so I'm good. It passes the vertical line test, so therefore it's a function. Now, if I look at this one, there are several places I can draw vertical lines that work, but if there's any one place that it fails, It fails the vertical line test, and that means it's not a function. So I drew one kind of in the middle on the left through that ellipse, and you can see that it crosses the graph more than once, crosses here as well as here. Now below we have the graph of a parabola, and let's think about that. Can you draw any vertical line that's going to cross through that graph more than once? And in this case, it's not possible. This passes the vertical line test, so therefore it's a function. And last, here's another example that is not a function because I can draw things, any vertical line on the left side of the y-axis is going to fail the vertical line test, which means it's not a function. All right, that wraps up this video. Another quickie on determining if graphs represent functions and evaluation of functions. Next time, we're going to talk a little bit about looking at graphs and determining domain and range, and also finding intercepts from equations. And I will see you then.